Hi, everyone. Thanks for joining. I'm Brian Huhn, a Senior Product Marketing Manager for Citrix NetScaler. I'm sure we all are very aware of the fact that AI is moving fast, and many organizations are eager to take advantage of it. But making AI projects successful at scale is a difficult balance to strike. It requires creating real value from the project while also managing the right guardrails and controls, as well as managing efficiency and other LLM-related costs. That's why today I'll be focusing on how NetScaler helps organizations strike that balance by providing the governance, cost controls, and visibility needed to scale AI profitably and safely across the enterprise. Before we jump into NetScaler, it's worth stepping back and looking at the broader challenge the industry is facing with AI adoption. Gartner projects that 35% of AI projects will be abandoned by 2029. Now, that number is actually down from roughly 60% of projects being abandoned in 2024, which shows the industry is learning, but it also makes clear that a meaningful percentage of AI initiatives are still failing to deliver long-term value. And these projects aren't being abandoned because AI, quote, doesn't work. Gartner points to issues like weak governance and risk controls, operational inefficiencies, and unpredictable ROI, to name a few. What this tells us is that a critical factor in the success of AI projects is creating the right environment for them to thrive. That means putting proper guardrails in place, managing efficiency and cost as usage scales, and having visibility into how AI is actually performing. And that's exactly why NetScaler is focusing on solving this problem. This is where NetScaler AI Gateway comes into the picture. NetScaler AI Gateway provides a centralized control point for how all your AI tools and projects are accessed and used across the enterprise. At a capability level, AI Gateway applies familiar NetScaler strengths to AI workloads. It governs AI traffic across models and environments, optimizes routing and performance, and enforces policy and security controls while providing visibility into usage and cost. This includes things like intelligent routing across models, usage-based controls tied to tokens, and policy enforcement that applies consistently across teams and applications. From a business perspective, this translates into four core outcomes. First, streamlined operations by simplifying how AI is integrated and managed through a single control layer rather than a collection of one-off solutions. Second, enhanced efficiency by optimizing performance through intelligent routing, load balancing, and scalable AI interactions. Third, security and governance by enforcing consistent access controls, policies, and compliance guardrails as AI becomes embedded in critical workflows. And finally, cost management by tracking AI usage, controlling token consumption, and preventing runaway spend as adoption grows. Now, ultimately, AI Gateway turns AI into a managed enterprise service rather than an unmanaged set of integrations. That's what allows organizations to scale AI safely, efficiently, and profitably. This functionality is available in NetScaler's 14.1.66.x software release. So before I move on though, I want to talk through a few real-world use cases to help bring AI Gateway to life for you. These examples show how the capabilities we've discussed can translate directly into business value. The first use case is for token-based traffic management, which focuses on one of the most practical challenges organizations face as they scale AI: cost control and fair usage. Now, with LLMs, cost and performance are directly tied to token consumption. The more tokens processed, the more compute is used, and higher the cost. Without guardrails, a small number of users or applications can unintentionally consume a disproportionate share of tokens, driving up costs and degrading experience for everyone else. In this example, let's say we have two users who we'll call Mr. Greedy and Mr. Polite, and both use AI in very different ways. Mr. Greedy's work naturally consumes a large number of tokens, while Mr. Polite's use cases are lighter but just as important. Without controls in place, Mr. Greedy could easily monopolize available tokens and degrade the experience for others. NetScaler AI Gateway enforces user-level rate limits based on token consumption, ensuring fair access across teams. And by sending detailed usage data to Splunk or your observability platform of choice, organizations gain the visibility needed to make informed, data-driven adjustments over time, rather than relying on anecdotal feedback. From a business perspective, this delivers three key benefits: controlled AI spend, consistent performance for all users, and the operational confidence to expand AI usage across the business without disruption. It's an easy-to-use control that has a measurable impact on both efficiency and budget discipline. Now, the second use case focuses on performance and user experience. Not all LLM requests behave the same, and response times can vary based on model load, region, and underlying infrastructure. NetScaler AI Gateway can make real-time routing decisions based on token latency, directing requests to the model or instance that is responding fastest at the moment. The business value for this is straightforward: faster, more consistent responses for end users, better utilization of your AI resources, and fewer performance-related escalations. This allows organizations to deliver a reliable AI experience at scale without over-provisioning capacity or having to manually tune routing logic. And then for this final use case, we're going to focus on governance and security, which are especially critical as AI is becoming embedded in regulated or sensitive workflows, or even both. Now, NetScaler AI Gateway enables prompt templating, allowing organizations to control how AI is used by design. This ensures AI responses stay within approved boundaries. So, for example, keeping a healthcare-focused LLM strictly within clinical topics when a user sends a query. So you can't ask it about geopolitical stuff, for example. Or also preventing competitors from extracting proprietary or sensitive business information LLM, like the secret sauce of your company. It also helps reduce risk and unnecessary usage that can drive up costs. In addition, there's another really cool piece here NetScaler AI Gateway uses called LLM redaction. This ensures that sensitive data, such as PII, is never sent to or returned from the model. From a business perspective, this reduces compliance risk, protects brand trust, and enables organizations to deploy AI confidently in environments where data protection is non-negotiable. Now that we've covered a NetScaler AI Gateway, I want to move on to another very exciting topic: MCP and MCP servers. But before we talk about NetScaler's MCP server specifically, let's take a step back and talk about MCP at a high level for those who may be unfamiliar. So I've said it a few times, but the Model Context Protocol, or MCP, is a standardized way for AI agents to connect to enterprise applications and systems. MCP acts as a bridge between the AI agent and the application that holds the information, allowing the agent to request specific data and receive structured, trusted responses without direct access or custom integrations. Those who already know MCP know that its adoption is rapidly accelerating as organizations deploy AI agents across critical industries, where controlled access, auditability, and consistency is critical. As AI expands beyond simple chat interfaces, enterprises are converging on MCP because it provides a repeatable way for AI to interact with real systems. To make this concrete, let's consider a financial services example. We have a user who asks an AI assistant, "Do I have any accounts that exceed their risk threshold today?" The AI agent uses the Model Context Protocol language to talk to an MCP server that then connects to the risk management application that owns the data, retrieves the current information through a governed interface, and then returns a clear answer to the user that's using the LLM. The key point is that MCP relays information between the AI agent and the underlying system, rather than embedding the logic directly into the AI model. So that relay model is what makes MCP so important for an enterprise AI. Now, let's talk specifically about MCP Server for NetScaler Console. Today, the MCP Server provides a governed MCP interface into NetScaler Console. This allows AI agents to securely query operational information such as application inventory, ADC health, deployment details, and overall environment status. This means reducing the time and effort required to gather operational context, improving visibility across environments, and enabling your AI tools to quickly provide you with accurate real-time insights while maintaining strong controls and auditability. Importantly, this is just the starting point though. MCP Server for NetScaler will continue to evolve with expanded coverage and additional capabilities planned over time. Looking ahead, this same MCP-based foundation opens the door for more advanced use cases, including an MCP server that supports directly on ADCs, where your AI can actually assist in configuration changes, policy updates, WAF enablement, and all the other NetScaler capabilities. Meanwhile, though, all under an enterprise-grade governance. So we want this to be driven by real customer needs. So all of you here today, as we continue to build this out, we'd really love to hear what MCP-based capabilities would be most valuable for your environment. So please let us know in chat, reach out to your representatives, or however you want to contact us. Now, as a final bonus topic, I want to touch briefly on security, and specifically how NetScaler is addressing emerging risks around self-hosted LLMs and MCP servers. At the end of the day, LLMs and MCP servers are exposed through HTTP APIs, just like any other modern application. That means they're subject to many of the same attack patterns we've seen for years, but with new twists introduced by AI-driven inputs. MCP servers in particular often run with elevated privileges and may trigger internal APIs or backend logic. At the same time, LLM requests are untrusted user input by design. So attackers can embed things like prompt injection patterns, malformed JSON, or oversized payloads that attempt to bypass application logic before traffic ever reaches the model or execution layer. So that's why having a first line of defense still matters for these new things. NetScaler's first wave of WAF protection for LLMs helps stop malicious requests early, before they lead to things like unauthorized data access, back-end exploitation, or downstream system impact. From a business perspective, this is going to reduce the risk of data exposure, service disruption, and costly incident response, while allowing teams to deploy self-hosted AI and MCP services with much greater confidence. These initial LLM focused protections are available today as part of the latest NetScaler WAF signatures update.